So guys, we are going to do the third method today, just to give you guys a little bit of a schedule. It's looking like today we'll learn the third method. This is my favorite. This is my go-to method, how to solve a system. Tomorrow I'll let you practice it one more day just to get used to it, make sure you feel really good. Wednesday is a half day for you guys. It's a professional day for teachers. They're letting you guys out a half hour earlier than normal, though, on a normal half day. Normally, you guys get out at 11:45. They're letting you out at 11:15. And classes will be about 25 minutes each. So you'll still see all of your classes on Wednesday, but they'll only be for about 25 minutes, okay? So when I see you on Wednesday, I'm going to give you a quiz review, reviewing graphing, substitution, and elimination. And then Thursday will be our quiz on solving a system. And it'll say, solve this problem by this method, solve this problem by that method, and so on. I'm trying to get it on Delta Math, but it might be on quizzes. Sorry. All right, so here we go. So the third method, the elimination method, is based off of this. Guys, when you add every single one of these together, they all have the same answer. What do they all add up to? 0. Because that's what's happening when you add opposites. -8 and +8 are opposites. -5x and 5x are opposites. When you add opposites in math, they always add up to 0. And that is what the elimination method is going to use to base its entire solving process off of. That when you add opposites together, they will, if you will, eliminate from the problem and cancel out. So this is what the elimination method is going to use. So let me give you today's notes so we can start that method. These are pretty quick for me, all right? Because I do think this is one of the most straightforward methods that we learn. All right. Hopefully you will kind of remember it. Oh, almost.
Yes.
Okay, so really quick, before we start elimination, guys, no matter how you solve a system, whether you solve it by graphing or substitution or this method elimination, there's only 3 kinds of answers. When you solve a system, this better be one of the answers that you get. Can you name one of the 3 answers that you can get, 3 solutions? Infinitely many. IMS. When we were graphing, you would have gotten infinitely many solutions because you would have discovered that they are the exact same line, that they have every single x and y value in common, and therefore they have infinitely many solutions. When it was substitution, you saw IMS present itself because the variables cancel out, and you are left with a true statement, like 5 equals 5, or 10 equal 10, or -8 equal -8. But you were left with some type of true statement. And that's how you knew it was IMS. All right, give me another kind of answer. What else can you get when you solve a system? Go ahead, Brennan. No solution. Maybe there are no x values and no y values that will make both equations true. When we were graphing, we saw that no solution happens when they're parallel lines, and they never meet, and they never have a common x and y value that can make both equations true. But then with substitution, no solution represented itself or presented itself by the variables canceled out, they disappeared from the problem, but then you were left with a false statement, like 8 equaled 12. Or -2 equals 7. When you are left with a false statement, that's bad. That's no solution. So that's still going to happen here. All right, and then what's the other kind of answer that you probably get 98% of the time? One solution. You find one x value and one y value that will make both equations true. Okay, so please, guys, these are the only 3 things you're allowed to put on the answer line. Those are the only 3 answers you get to a system. All right, let's do this elimination. So we've learned how to solve by graphing, check. We've learned how to solve by substitution, check. Now we're going to do the elimination method. And the elimination method is based off of the fact that when you add opposites together, they always eliminate and add up to 0. Okay? This is what the entire elimination method is based off of. When we solve by elimination, guys, they're going to tell you to take the two equations, they're going to tell you to add them together to make one new equation. But when you add them together, we want the two equations, when you add them together, we want one of the variables to be eliminated from the problem. You want to be left with a third equation that only has one variable in it. All right? In order for one of the variables to be eliminated in that addition step, you need the same number but opposite sign in front of one of those variables. So you would need a 2x in one of the equations, then you would need a negative 2x in the other equation, so that when you add them up, your x's will eliminate. Maybe you have a 5y there in the one equation. Then you would need a negative 5y in the other equation, so that when you add them together, the y's will be eliminated. You have to have the same number but opposite sign in front of one of your variables in order for the elimination method to work. And that's what we're going to do, all right? So before you add the two equations together, you might have to fix it. You might have to fix the problem so that one of the variables does have the same number but opposite sign in front of it. And the way we'll fix it is by using multiplication. That's how we're going to set the problem up. All right, let's do it. So guys, look at example number 1. We're going to solve this system using the elimination method. So you are given one equation that has an x and a y in it, and a second equation that has an x and a y in it. They represent the same missing numbers. We're trying to find what number could you plug in for both x's and both y's that make both equations true. So guys, if you notice, this x has a 2 in front of it. This x has a negative 2 in front of it. They are opposites. So let's add these two equations together right now. If I add them together right now and make one new equation, watch what happens. What's 2x plus negative 2x going to add up to? 0. The x's have been eliminated from the problem. What is 2y plus 3y is going to add up to? 5y's equals what's 40 plus negative 20. You are left with a third equation, but that third equation only has one variable in it. So now we're going to be able to solve it by doing what operation? Divide both sides by 5. And guys, you got your first answer in about 5 seconds. We get y equals 4. But it is a system, so now you need your second answer. And now you can get your second answer by taking 4, plugging it in for that y, and solving for that x. Or you can plug it in for that y and solve for this x. You have options. Go ahead, Dad.
So when you eliminate them, when you plug it in, they're still gone?
No. When you go back to the plug-in, you go back to the original problem itself. Good question. All right, so I'm going to pick the top equation to go back to, and I'm going to plug 4 in. So that's going to leave me with 2 times x plus 2 times not y. We just found out y is 4. And then that equals 40. And now we can solve this. Let's clean it up. 2x comes down. What's positive 2 times positive 4? Positive 8. And now it equals 40. And everybody can solve this equation. Let's move our 8 over. 2x equals 32. What's the last step I have to do to get x? Divide by 2. And we find out x needs to be 16. So that means as long as x is 16 and y is 4, it will make both of these equations true. It also means that had we graphed, these lines would have met at the ordered pair 16, 4. So we're still going to write our answer as an ordered pair. All right, so guys, that's the elimination method in a nutshell. You're trying to add the two equations together so that a variable gets eliminated. You're only left with one variable, and you get your first answer rather quickly. All right, but guys, hold the phone. This problem was set up perfectly for elimination because it already had opposite numbers in front of the x's. So it was already set up where the x's were going to be eliminated. Do you think every problem they give you is going to have opposite numbers in front of a variable? Of course not. So it's not always going to be that simple, but that's what we're trying to make it. We're trying to make it that simple. All right, so everybody look at example 2. Same thing. They've given you two equations that have an x and a y in them. We're trying to find out what those missing numbers are that will make both of these equations true. Guys, if I add them together right now, nobody do this. Just look up here. BB3. She just switched to a different class. I don't know exactly what class it is. Thanks. All right, bye. All right. So if we were, just for giggles, guys, if we added these together right now, don't do it, but if I did it, what's 5x plus 1x? 6x. What's 2y's plus negative 3y's? Negative 1y equals what? 16? Guys, all it did was get you a third equation that still has an x and a y in it. So you do not want to add these together right now. It didn't help us at all. It just made a third equation that we couldn't solve. So you don't want to add them together yet because nothing gets eliminated. We have to have the same number but opposite sign in front of x or y in order to be ready to add them together. All right, so guys, here's how you're going to pick. Let's look at the x's first. You have a 5 and a 1 in front. Go to the little number. 1. Can you multiply a 1 by something to become 5 or even negative 5?
Yeah.
Very easily. So he's 5. We need him to be negative 5. What would you times this by to make it a negative 5x? Negative 5. So all you'd have to do to get your x's to eliminate is times the entire bottom equation by negative 5. And then you'd never have to change the first one. It'd be great. All you'd have to do is change one equation. But time out. Let me give you all the options. If you're like, no, Hardy, I'm not convinced with that. I like to eliminate y. Okay. If you wanted to eliminate y, go to the little number. Don't worry about their signs. Go to the little number 2 and ask yourself, can you multiply 2 by anything to become the bigger number 3? No. So if the little number can't become the big number, then you have to find a number that they can both become. So what number, preferably the smallest one, because there are lots of answers to this question, what number can 2 and 3 both become through multiplication? 6. 12, 18, a lot of stuff works, but 6 is the best. So then, in order to get the y's to eliminate, I'd have to change both equations. I could make this positive 6 by timesing everything by 3. I could make this negative 6 by timesing everything by 2. So if you ask me, you can do either one. But the smartest choice is to eliminate x because it takes the least amount of work. So let's eliminate x. So if we're going to eliminate x, I need to make that a negative 5x. And we said we could times everything by negative 5. Now, I don't like to mark this up too much because to go back and plug in, I want to be able to see my 2 original equations. All right, here we go. What's negative 5 times x? Negative 5x. What's negative 5 times negative 3y? Positive 15y. Beautiful. And guys, don't forget this poor little guy. Everyone forgets him by himself. It equals what's negative 5 times negative 3? 15. Now, bring down the first equation that you've never even had to change. 5x, oh, look at that, plus 2y equals 19. Now, those x's, man, they are going to eliminate. So let's add them together. When I add them together, I'm going to get what happens to my x's. Cancel out. They're eliminated. What's 15 plus 2y's? 17y's equals 15 plus 19? 34. What is the only thing you have to do to solve for y? Divide by 17, and you find out your first answer is 2. Y has got to be 2. All right. Now, in order to find your second answer, you have options. You can take 2 back to this original equation, plug it in, solve for that x. You can take 2 back to this y and solve for that x. I don't like to go back to any of the equations that I made. I only ever go back to one of the originals, all right? Or there's a third option that some of you might like, but let's do this first. All right, I'm going to choose to plug, I like the bottom equation better. So I'm going to choose to plug into this one with my 2. So I'm going to get x, subtract 3, times, not y, we just found out y is 2, and then it equals negative 3. So let's clean this up. X, what's negative 3 times positive 2? Negative 6, and it equals negative 3. What is the only thing you actually have to do to get x by itself? Add 6. And when I add 6, I get x equals positive 3. So now you know x had to be positive 3, and y had to be positive 2 to make both of these equations true. That is the solution to your system. All right, can I give you a third option? Guys, coming off of the substitution method, some students are like, Hardy, I can't take it anymore. If you make me plug one more thing in, I'm gonna die. I can't plug anything else in and solve. So another option, if you're totally over the plugging back in, I call it double elimination. We got our first answer by eliminating X. You can get your second answer by, guys, go back to the beginning, start over, except this time, eliminate Y. And then if you eliminate Y, you'll be able to solve for X. So it's called double elimination. If you don't want to plug in, because guys, sometimes your first answer is going to be a fraction. And now you have to plug a fraction back in. So if you don't want to plug no fraction back in, then you're just going to start over and eliminate the other variable. So guys, we eliminated X by getting 5 and negative 5. Let's eliminate Y and see how the double elimination works. What did we say 2 and 3 can both become? 6. So I could make him my positive 6, and I could make him my negative 6. So if I do that, I could times the whole top by 3, and I could times the whole top, the whole bottom by 2. So if I did that, I would get 15x, and then I would get 6y, which is what I'm aiming for, equals 3 times 19, 57. All right, times the whole bottom by 2. 2 times x is 2x. 2 times negative 3y is negative 6y. Look at that. Look at it. Equals 2 times negative 3 is negative 6. So now when I add them up this time, now my y's will go away, and I'll be able to solve for x. And I'll get 17x's equal 57 plus negative 6 is 51. Divide both sides by 17, and you find out x is 3 this way, just like we found out by plugging it back in. So I'm not saying you have to do double elimination. I just want you guys to have it. If you're on a quiz and the first answer is a fraction and you plug it back in, you're like, God damn it, I cannot get this answer, then maybe you should just say, you know what, fine, I'll just go eliminate the other variable this time, because the elimination to me isn't hard, all right? All right, so now that you have another option, let's go to example 3. What? I know. I always forget I have it, and I just feel like it's quicker for me to go over there anyway. But I do have it, and I think I'm actually more mad I didn't buy the keyboard to go with it, but, I'll get over it. All right, here we go. We're almost there. All right, if we have to solve this using elimination, guys, should I add them together right now? No, I'd get 14x's and 7y's. It wouldn't help a thing. You need opposites. You have to have the opposite number in front of a variable. Let's see what our options are. If I want to eliminate x, go to the little number. Can you multiply 6 by something to become the big number 8? No. So that means you'd have to find a number 6 and 8 could both become, and you'd have to change both equations. Guys, there's lots of numbers 6 and 8 can become, but who's their smallest number they can both become? 24 is actually the smallest one. So you'd have to make one of them a positive 24, and you'd have to make the other one negative 24. It doesn't matter which one's negative, just one of them has to be positive and one of them has to be negative. And that's how we could eliminate x. Or, if I want to eliminate y, go to the little number. Can you multiply 2 by anything to become the big number 5? No. What number can 2 and 5 both become, and I'll change them both? 10 is the smallest number. So now it's like a personal choice. Do you want to work with 24s or do you want to work with 10s? I'm kind of feeling 10s. So I'm going to choose to eliminate y. I like their number better. All right, so let's choose for this to be my positive 10. What are you going to times them by? 2. Whole top multiplied by 2. All right, then he has to be my negative 10. So what are you going to multiply him by to make him your negative 10? Negative 5. And guys, it always trips students up. They're like, wait a minute, I can times this equation by 2 and this one by negative 5? Yeah, because you have to make them opposite numbers. All right, let's do it. 2 times 8 is 16x. 2 times 5 is 10y. That's what we were aiming for. Equals, don't forget about polar 22. 2 times 22, 44. The whole equation has to get multiplied by that number. All right, negative 5 times 6x, negative 30x's. Negative 5 times 2y, there it is. That is beautiful. I got opposites. And it equals negative 5 times 13, negative 65. Let's add them up. When I add them up, 16 plus negative 30 gets me how many x's? Ooh. Negative 14x's. What happens to my y's? Just as we planned, they are eliminated. Equals 44 plus negative 65 is definitely negative because he's the bigger number. And 21 is their difference. All right, Now we got to divide. And we're going to divide by negative 14. So we're going to get a positive answer because a negative over a negative goes positive, but just 21 divided by 14. So we're getting a fraction. We're going to reduce it. 7 goes into both, so what does it reduce to? 3 over 2. So your first answer is 3/2. This is what I'm talking about. You're like, no, I'm not doing it. I'm not plugging a fraction back in. Then that's fine. Then go get me some 24s and negative 24s and eliminate x this time. If that's something you want to do instead of plug back in. Otherwise, you are now allowed to take 3/2, plug it in for that x, and solve for that y. Or take 3/2 and plug it in for that x and solve for this y. I don't care how you do it, guys. But right now, everybody get me the second answer y. Whether you plug it in or whether you eliminate again, I want you to get me that answer. I'm going to do both ways up here, and you can just compare it to whichever one you did. So you're either plugging it in or you're doing the elimination again. Start over from scratch and eliminate the other variable.
What do you have to do? What is the bottom half of the okay, by 8?
Say it again. And again, it doesn't matter which one you plug back into, pick one. I like the bottom one. It actually winds up being a nice fraction to plug back in. Say it again.
I got.
Did you get your first answer? Did you plug in or double eliminate? Plugged it back in.
Honestly, I don't know.
Did you plug it into the top or bottom one? I plugged it into the bottom.
Oh, I did the thing where I eliminated again. Oh my god.
That's fine. Eliminate again. I'm doing it right now. I'm a huge fan of that, especially when the first answer is a fraction and you think you're going to make a mistake.
I got a fraction. Can I make it into not an improper fraction back to a direct?
You can use it as only if it's a decimal. Like this is 1.5. If it was 1.3 repeating, then no, because you could never estimate that. You'd have to round it, and the minute you round it, the answer is not precise anymore. So if it's a nice decimal, sure.
I'm talking about like this.
The second one shouldn't be a fraction.
Yeah.
Now this time your x's should eliminate. You're left with 7y's equaling 14. Divide both by 7. And no matter which way you did it, you should have found out that y was 2. The only thing I didn't show up here is for anybody who plugged into the first one. Still should have got 2. How do we feel? Do we feel okay? All right. Do any of you think you might be up for the double elimination on some problems if you get a fraction? It might just be like something to have like in your back pocket. Like if you're on a test saying, why ain't I getting this answer? Then you know, maybe I was just trying to eliminate, okay? Go ahead, Deb.
Why are you so small?
What do you mean small?
You got 15y and I got 30y and then you got 8y and I got 6y. And you got 66 and I got 32.
What did you times it by to make it 24? Oh, wait, did you? What? But 6 and 8 would have made them 48. So you would have had 48 and negative 48. That's why. That's the only reason why. But again, see how we still get the same number. All right? All right, last one. One more. So on the last problem, I just wanted to show you guys, because some of you might be thinking like, yeah, this is it. This is going to be my go-to method. I like this a lot better than substitution and graphing. The problem is, when you go to solve a system by elimination, we want x and y on one side equal to a number so that everything lines up. Well, some problems, maybe they're better set up for substitution. And you're like, I don't want to substitute. I want to eliminate. Well, then just know you are allowed to move things around and get x and y on one side of the equal sign in that standard ax plus by equals c form. You are allowed to move things around to get it set up for elimination. So in this case, I would add my 3 x's over to get my x's and y's together equal to a number to get ready for the elimination process. So I would move them over, and then I would get positive 3x minus the 6y that was there equals the positive 7 that is left. And now it's better set up for the elimination method. Same thing down here. Let's move y to the same side as x. Let's add our y's over. Let's move some things around. Just a little manipulation. And then I would have negative x plus these 2 y's equal the positive 6 that is left. And now we're in business for elimination again. So you are allowed to move things around for elimination if it's not set up for elimination. All right, now guys, when it comes to elimination, and I know I need these opposite numbers, I am a sucker for a just variable because I know that's going to be really easy to make him the opposite of the other number. So if he's a positive 3, what do we need him to be? A negative 3. What are you going to times a negative x by to make it negative 3? Just a 3. So I could easily times this equation by 3 and my x's could eliminate. So I'm going to do that. I'm definitely doing that. All right. And then something happens that we didn't plan on happening. So I get 3 times negative x is negative 3x. 3 times 2y is 6y. And then 3 times 6 over here is 18. All right? I don't even have to touch the other equation, so let's just bring him down. 3x. That's what I planned on. This is what I didn't plan on. Whoa. Okay? And then equals 7. When you go to do your elimination and you add them together, what happens to our x's? Cancel. As planned. But what we didn't plan is what happens to our y's? They eliminate. So what would you say is left on the left side of this problem? 0, nothing. And then it equals, what's 18 plus 7? 25. 25. My variables completely eliminated. The x is eliminated, the y is eliminated, they're gone. There's no more variables left. So 0 is left on the left, but this number is left on the right. So guys, you're left with this statement that says 0 equals 25. Is that true? No. So if that's bad, what would you say this answer is going to be? This is a no solution. Your variables canceled out, but your numbers didn't. Go ahead, Darren. Because 3 times this 6 over here.
Oh, I must have.
Everybody forgets the number by itself. All right, so this would be a no solution. Go ahead, Kayla. Yeah, 1 second. So we can say one more thing, and then Darren can go too. No solution. So guys, the only other thing we didn't see is where's IMS? This is what's going to happen. If you get IMS, your X's are going to be eliminated, your Y's will eliminate, and you're going to get 0. They're going to be gone. But the cool thing is with IMS, the numbers cancel too. So you must have had like an 18 and a negative 18, or a 7 and a negative 7. And the only way to get IMS is when everything cancels and you get 0 equals 0. That is how IMS will come out in these problems. Everything gets eliminated. Your numbers, your variables, everything. And you are left with 0 equals 0. Is everybody okay with that? Okay. All right, perfect. All right, so you do have a homework tonight on Delta Math. Tomorrow, like I said, we come in and practice this method one more day, and then we review, and then we quiz. Darian, you can go, and who was that? Caleb? Do anybody need me to sign a pass, or do you have your passes?
I do. I don't want to.
All right, I'll sign it.